This is video homework for Tim Barron, Physics 350, Homework 8, Problem 5. They gave us two long coaxial solenoids that each carry current I. They gave us A as the radius of the inner solenoid with N1 turns and B as the radius of the outer solenoid with N2 turns. They want us to find the magnetic field in three regions: inside the inner solenoid, between the solenoids, and outside both solenoids. For part 1, the Gaussian surface of radius R is smaller than the radius of A and B. So we're going to go ahead and figure out B1 for the inner solenoid and B2 for the outer solenoid, and the answer to this part will be adding the two together, and you will see the answer that we get. Mu naught times quantity N1 minus N2 times the current. For part 2, the Gaussian surface of the radius R is going to be between the smaller solenoid and the larger solenoid. So we're once again going to add those together, but the Gaussian surface is outside for the inner solenoid, so there's no magnetic field. So we have B1 equals 0, and we're going to use the same formula to find B2, and that will also be our final answer, which is minus mu naught times N2 times the current. And for part 3, the Gaussian surface of the radius R is going to be larger than both radius A and radius B. So since it's outside the inner and outer solenoid, there's no magnetic field due to the inner and outer solenoid, therefore it's 0. In conclusion, to solve a problem like this, you must look closely at the inner and outer solenoids. The magnetic field will be the sum of the solenoids. If the Gaussian surface is outside of a solenoid, the magnetic field will be 0. And if the Gaussian surface is outside of both solenoids, the entire magnetic field will be 0.